Okay, this question is about collision, and this is for 8 marks, so I have adjusted the timer to 8 minutes. Right, let us start solving this problem. So as you see here, two identical blocks of mass 0.17 kg and length 0.5 meters, 0.5 meters are traveling towards each other. Okay, one block A, one block B, both of them are traveling towards each other with the same speed. Mass, what is the mass here? Mass is 0.17 kg. Okay, and distance between them is 0.9 meters. Okay, assuming surface is frictionless, right? The initial distance between the centers of the block is 0.9 and both blocks are moving at speed. Okay, what will happen? After some time they will collide. Where will they collide? They will collide exactly at the middle because both of them are moving at the same speed. Okay, so after some time this will collide here, right? Determine the time taken for the blocks to come into contact with each other. Okay, so what do we do here is that, so what is, we know that, okay, they will meet at the center. Okay, so what we'll do is, let us find out what is the distance between here to here. See, there are two methods to solve this. The first method is known as the relative velocity method, relative motion, which I am not doing it here because at many schools we do not teach this relative velocity. At sometimes we do skip this also, and students have a difficulty in understanding this. So I'm not doing this method. I will go by another method. Okay. So now what we do is, so here the distance between them is, since it's half, this should be 0.450 meters over here. Similar, the same thing happens over here also, 0.45 meters. Now you see this has a dimension. When it comes and hits here, now the midpoint, this is the midpoint, this is the place where the center of mass is present, right? So therefore to this point, okay, so it's here, here. So this whole thing is 0.05 meters. So I assume, so this distance is 0.025 meters over here, right? So therefore, now what's happening over here? The net distance at which they come in contact is seen to be 0.45 minus 0.025, which should be 0.425 meters. This is what it is, which means both of these blocks travels the same distance of 0.0425 meters. Distance equal to 0.425 meters was the distance traveled by the blocks, the center of the blocks, I mean to say. Okay, not the other edge of the block. Okay, so therefore, and then the velocity of the block was seen to be 0.18 meter per second. The time taken, how do I calculate? This should be S by V. So what should I do? I can do 0.425 divided by 0.18. When I do this, what is the answer I get? Let me find out using my calculator. So this should be 0.425 divided by 0.18. I get the answer as 2.36. 2.36, which is nearly 2.4 meter per second. Okay, this should be your right answer. Then next one. Did we finish the first one? Yeah. Second question. As a result of the collisions, the blocks reverse the direction in the direction of motion and travel at the same speed as each other. So you had one block here and you had another block. When they hit over here, this came with a velocity of let us say v, this came with a velocity of v, and upon hitting, what happened? So they travel at the same speed as each other. They reverse their direction. So after some time, what happens? This block goes like this. This is your block A, this is your block B. This block A goes like this and block B goes like this. Okay, anytime you have to picturize it. During the collision, 20% of the kinetic energy of the blocks is given as thermal energy. This is heating takes place. 20% is lost. Okay. State and explain whether the collision is elastic or inelastic. Definitely it is inelastic. Why inelastic? Because energy is lost. Right? It's very clearly said 20% of the kinetic energy of the blocks is given off as thermal energy. So therefore it is lost. So it is an inelastic collision. Very easy. Show that the final speed of the blocks relative to surface is 0.16 meter per second. Now in a collision, you see, this conservation of energy cannot be applied because energy is lost. Also, it's not valid. Now conservation of momentum can definitely be applied, right? So what is the momentum of the first object when it came like this? It is m1 into u1, m1 into u, m1 into u. And what was the momentum of second object b? B was coming like this. This was the momentum. B's momentum was seen to be m2 into u. M1 and m2 were same, right? Okay, but this was negative. And then what happened was that they joined together, and as a result of it, they went away from here. Okay, so then this should now be equal to, what? Momentum of this one, which should be m1 into a minus m1 into a minus m1 into v1, and then both of them move with the same speed. Okay, minus plus m2 into v2, right? Now what is the momentum of these two? See, m1 u1 plus, now before that, what we do is, okay, let us not do this one. What we'll do is, because some amount of energy is being lost, so what is the kinetic energy of the first object? Kinetic energy of the first object, just a moment. Kinetic energy, the input energy, that is the incoming energy of both the objects, were seen to be half mv square, which was seen to be equal to half into 0.17 multiplied by 0.18 square. This was the incoming kinetic energy, okay, of the blocks. So which you can calculate some value, and then of which 20% of this kinetic energy is lost, right? And therefore now what will happen over here? So this will now be equal to, let us calculate this value to get the correct answer. So we got 0.17 multiplied by 0.18 star 0.18 is equal to 0.005508 divided by 2. I am just calculating the kinetic energy of one block, which should be 0. How much is it? 0.002754. 002754 joules. This was the kinetic energy of one of the blocks. 20% of the kinetic energy of this block is lost. I'm not taking both the blocks, I'm taking only one of them, right? So which means of this block is lost, which means the remaining energy of the block is equal to how much? 80% of this value, right? So which means this should be equal to half mv2 square, that is the final square, right? Which should be 0.8 multiplied by 0.002754. Okay, let us calculate this value. So this multiplied by 0.8 is equal to something like this, which is 0.0022232. What do I need? I need v2. V2 is equal to 2 into 0.002232 divided by m whole square root, right? When I do this, how much do I get? So I get the answer as star, oh, time is already up. Anyway, we'll do it. Star 2 divided by, what is the mass? 0.17. So when I do this, I get the answer 0.2592. Take the square root of this, I get the answer 0.16 meter per second, right? So we arrived at the final answer. Okay, next, that's it. I think this is the end of this particular problem. Okay, so anyway, we've taken one more minute more, which can be compensated in the previous problem. Thank you.